Professor Zawala. Today we're going to be going over the West African Examination Council Senior Secondary School Mathematics for Liberia. We are dealing with the section on algebraic processes and the subsection change of subject of a formula or a relation. So we already know in mathematics that what are formulas? A formula, for example, would be one of the most common ones. Let's take one of the most popular formulas, or two of the most popular formulas. The first one, let's talk about distance. D is equal to rate times time. Very simple and fairly easy formula. What this formula does is that if we want to know how far we travel, knowing the speed at which we are traveling called the rate, and how long it took us to travel, we can determine the distance we travel. Likewise, we also have a very popular formula from physics, which is based on Newton's second law, which is force is equal to the mass times the acceleration at which the object is moving. Now, so we can determine the force when we know the mass and acceleration. Now, for each of these problems, the situation before us could be different. For example, in the first case, we could know the distance. We could know the time it took us to cover that distance, but then we need to find the rate at which we were traveling. So that means in this problem, D equals to RT. Since we're interested in knowing the rate, we need to make R the subject of the formula. D equals RT. So basically, we need to solve for R. We need to isolate the R. So how do we do in this case? To get the R by itself, we're going to divide by D. So R is equal to D over T. Now I know you're wondering and saying, wow, it's kind of easy, but quite frankly, on the WAEC, it's extremely unlikely that the problems you face will be that easy. So what are some of the possible problems you could face? Let's try some examples now. So I'm going to try to see if I can do about 5, 6 examples. So this is example 1. And the examples that I'm giving you basically is after I've done a lot of research on past exams, and not just in Liberia, but also in other countries of the WAEC. So you have this, so we need to solve for XC. So that means we need to get X sub C by itself. So X sub C is under the radical. So to get it by itself, we need to get rid of this radical. So let's start. So the first thing we need to do is to eliminate the radical. So how do I eliminate the radical? It's a fairly easy concept that when I have a radical, I can eliminate it by squaring a radical. So that's what I'm going to do. But I cannot square one side and leave the other side. So I'm going to square this radical in its entirety and then square this. So what I have then is basically I have Z squared is equal to, now the square root and the radical cancel here, is equal to R squared plus X sub C squared. Now to get X sub C by itself, I will minus R squared from here. And I'm not going to put it directly under the Z because they are not like terms. And so I have Z squared minus R squared equals to X sub Z squared. Now, please allow me to write it like this. Z squared minus R squared. I haven't changed anything yet. I would have used the sense of the definition of equality. So then, but I'm not solving for X squared. I'm solving for XC. So I must eliminate this square. Now remember, when we had a radical, to eliminate, we square it. Now that we have the square, to eliminate it, we must take the square root of both sides. So that square root and square root cancel. I will have X equal to plus or minus Z squared minus R squared. So we've solved and we've isolated that. Now, let's do another example.
stated more like in words. Let's try another example stated in words. Let's do example 2. Now, so for example 2, if the volume of a sphere, so I want to be very brief, volume of a sphere given by V equals to 4/3 pi r cubed, where r is the radius. And I think they want you here to make r the subject. So that we must rewrite this problem so that r is the subject. So I'm going to move on this end, rewrite the problem over here, and then we're going to solve it together. So we've been given the formula for the volume to be 4/3 pi r cubed. So we need to make r the subject. The first thing I want to do is to get rid of the fractions from here. So I'll multiply both sides by 3. It's going to go. I have 3v equals 4 pi r cubed. My goal is to eliminate the r, so to isolate the r, so I need to get rid of all of this. And since it's a multiplication, I use the inverse, which is division. So this is going to cancel. And again, allow me to write this as r cubed is equal to 3v over 4 pi. Now, I need to get rid of that cube. Now, I want to take another approach here. Basically, I need to take the cube root. But I want you to understand, taking the cube root is the same as raising this to the power of 1/3, and the same thing over here to the 1/3. Because I want you to see why this cancels. That's why I'm doing it that way. I could have just done the cube root. So now I have isolated the r, and I'm going to write our answer in 2 ways. So I see that my answer is basically r is equal to 3v over 4 pi to the 1/3, and you understand that this is the same as saying, if we have this, it says that cube root 3v over 4 pi. So basically, we'll do one more, and I think this message will be very clear. Let's look at another example where we have this is example 3. So I have r is equal to h over 2 plus d squared over 8h. And we need to make d the subject. So we need to make d the subject. So, you know, many approaches here would be possible. But let's see what we're going to do here. So we want to make d the subject of this. So the first thing I want to do is to move every term that does not have a d in it on the other side. It doesn't have a d in it, so I want to move it across. So I'm going to have r equal r minus h over 2, and we'll be left with what? D squared over what? 8h. So next thing I want to get rid of everything that is on the side with the d squared. And wow, this problem is much easier than I thought. I can just multiply it by 8h, and I'll multiply this whole thing by 8h, or I can multiply each term separately by 8h. So that's going to cancel, and I'll quickly arrive at my answer without much work, because basically what I have now is d squared is equal to 8h r minus h over 2, and then I have to take the square root of both sides, and then I have d is equal to plus or minus. Now it's possible that your answer may not contain plus or minus like that. There could be one interested in the principal square root.
Because first of all, you are finding distance, and the distance most likely must be positive, especially in this case. Now, we could do more to this problem. Let's see if we want to do more. Yes, we can do more. So let's just do it because we don't know how far a typical problem like this will be reached on the WAEC. So let's do something here. So let's write 8HR minus 8H squared over 2. And then we're going to do some manipulation here. I'm going to write this with a denominator of 2. So this is basically 16 over 2 HR minus 8H squared over 2. Now how did I get a 16? 16 divided by 2 will be 8. So then I haven't changed anything. So then I can just keep this 2 at the bottom here. And what I have here is going to be 16. I could take 8 out and take an H out. I will have 2. I will have 2 R minus H. And then if I divide this, I can further reduce this to 4H 2 R minus H. And that's basically what I can do to have it in a very simple form. So actually when I reached here, I thought I was done easily, but you see that we can further manipulate it and get it. So this is basically the kind of problems you will face when it comes to making something a subject of an equation. Again, as usual, go to www.fieldliberia.org. Go to our WAEC prep link and get some practice in. Thank you very much. This has been Professor Zawalo of the Foundation for Equity and Excellence in Education in Liberia, FIEL. We are on the web at www.fieldliberia.org, and this is part of our Open School Initiative of Liberia. Our goal is to provide quality instruction for every Liberian child to be able to realize the full potential in our highly competitive world. Thank you very much.